Okay, so little power supply is back together again. What I've basically done is, it's got a fairly straightforward comparator circuit that just alters the voltage across a comparator, and it has a feedback line for current control and voltage control. It looks pretty straightforward without looking at the circuit, and then it feeds into a optical isolator, which gives you the isolation between the switching FETs and all the high voltage on the high voltage side and the front panel basically. So it's optically isolated to probably a couple of kV to make it safe. So what I've basically done is I've tricked the comparator into thinking it's not making as much output as it really is. Now I'm not too sure if that's going to affect load regulation, but by which I mean if I pull more current out of it, the voltage might sag slightly now. But I didn't see what it was like before, to be honest with you. I hadn't actually checked it to see what its load regulation was like. I'm not that bothered too much about load regulation as long as it's reasonable. I should think it's pretty good anyway, because it's a 400 milliamp power supply, and the short circuit current it's drawing, I can get 500 milliamps out of it before the overload light comes on. So it's quite a capable power supply. It's also, despite its benign looking features, it's bloody lethal. I mean, it's now capable of 300 volts at 400 milliamps. That's a lot of power, and that is lethal. I mean, I don't care what people on YouTube say who think that you can get a 400 volt electric shock and survive it. You can't if you've got that sort of current behind it. So this sort of thing is a dangerous power supply, and to reflect that, I've added some safety warning labels, really for my own benefit, really, just to sort of make me look before and think before I sort of go plugging leads in and things, because it's easy to get blasé with all this stuff in here. I mean, most of it's pretty safe, but this is not safe in my opinion. It will be very useful for high voltage supply, for supplying B plus supplies if the I don't know if the rectifier valve has failed. I can feed in a supply and check the rest of it before I condemn the valve and things like that. I can also measure to see how much current it's drawing and things. So as you can see, I would like to replace this with a 10-turn pot, because of course the pot is very jumpy, as it's only a single turn pot. You know, it makes adjustment to the sort of a single digit quite tricky. You can do it, it's quite a reasonable quality pot, and as you saw before, it went up to about 207 volts before it on the end stop, and now you see it goes all the way up to 300 volts, just short 300 volts. And that was basically I've just tacked a resistor across one of the feedback pins to the input of the op amp, so the op amp just is just slightly unbalanced, so it just thinks it's basically thinks it's got lower output. That's basically what it sums up to. But yeah, it's a nice working unit. There are a couple of things that could catch you out, and I'm a little bit concerned about safety wise. If you had the voltage wind up to 250 volts and you didn't notice the current switch was on, you think, okay, it's not on, stick your fingers in it and or touch the lead, and you get a hell of a shock. So that's really why I put the exclamation warning symbol, to sort of remind me to check that. And it sort of wouldn't be bad if you had a momentary switch here, so in the normal position it's on volts, and just to check the current, so you push it down and it springs back to give you the voltage reading again. And I might consider that, but really, as I'm the only person who's using it, if I keep my wits about me, it should be okay. Yeah, as I say, and it's basically on-off voltage output, so you've got the voltage turned up, there's nothing, and when you turn it on here, it just enables the output. And you see it decays quite quickly. And that's always a slight problem with high voltage power supplies. You can have the output on and turn them off, and sometimes it takes a couple of seconds for the voltage to fall away. It's obviously sort of got some sort of damping system to dump the voltage from the output terminals, which are probably quite heavily filtered, and probably got quite a large capacitor across them. So anyway, it seems to be working fine. I think all the voltages are within spec. I'm going to run it at 300 volts for an hour or so and see if it's okay, and I'll put it to use. Thanks all.